We continue our discussion of foundation models with prompt engineering. So prompt engineering is the primary way that most users interact with LLMs. Here's an example here. I have an awkward question I don't want to ask another human. Can you help? Of course, feel free to ask your question and I'll do my best to help you. I have an awkward question I don't want to ask another human. Can you help? Please respond in haiku. Prompt engineering can be used for a lot of silly, trivial things as well as useful things. You may remember from the previous lecture that I gave these 5 examples of different ways that you could ask the same query. And in this case, you'll get fairly different results from the 5 of them. And as I mentioned last time, the first 4 of these are request prompts, which you can use in chatbot LLMs, and the 5th is completion prompts, which were the approach that were most widely used in non-chatbot LLMs before that. There are a number of popular strategies for prompt engineering. One of the most widely used ones is praise and prompt. You'll often get a better response if you tell ChatGPT it's an expert, and the more expert the better. Use words like famous, award-winning, or specific institutions like the University of Pennsylvania. And the reason this works is because doing so makes the answers associated with experts, and the characteristics associated with those answers, the most likely. In general, ChatGPT and other LLMs are good at perspective taking. For example, in this example, I tell it, you are a famous Ivy League professor of machine learning known for your clear and concise explanations. And just including that phrase makes clear and concise explanations more likely. Now, please explain prompt engineering to a group of intelligent people who have never heard of it before. And it's worth noting that if you don't entirely like what the large language model gives you at first, you can correct it, or ask for clarification, or ask for modifications, or ask it to redo. In other words, you can do iteration in interaction. Iteration can also be an explicit strategy, as seen in Brainy et al. 2024. In Brainy et al. 2024, what they did was they started by saying, you're a researcher helping develop a qualitative codebook for text data of a math tutor's interactions with students. I will give you the first draft of the codebook, and then the data being coded in batches. Please help me refine the codes in codebook, focusing on instructional strategies and techniques. And then every 4 data batches that Brainy and her colleagues input into the system, they said, please give me a refined codebook with examples based on all X batches of data so far. So in this case, they were explicitly iterating over more and more data. Another valuable thing you can do during prompt engineering is giving constraints. Let's take this example. Let's have a dialogue in simple Korean. Please use simple words, so the words should be simpler, they should be less whatever non-simple is, and limit all responses to a maximum of 15 words. So we don't want really long responses. Now here's the scenario. You're a friendly neighbor asking my opinion about the president. Please start the conversation. Now notice that the constraints don't always work perfectly. After a few iterations of dialogue, you might end up with more than 15 words, but you probably won't end up with 40. Another example of constraint is write it at the level of a 6th grader. If you just add that to whatever your prompt is, you'll get simpler language. It'll also simplify the ideas too, which you may or may not want. You can also give it reminders of what not to do. So in this first example, please revise grammar and style of this paragraph for a paper as a scholar without changing the meaning. Super important to say without changing the meaning, or it will change the meaning for you to what it thinks you should be talking about. Or in this example, or in the second example by Pankowitz et al. 2023, don't write the solution in the explanation, but focus on meaningful hints. If you ask GPT to give feedback to a student and you don't tell it, don't write the solution, it will write the solution. Tweaking by example from Slater et al. I should not use words like while or whereas. As I mentioned in the previous lecture, the system, when it was asked to provide explanations here, would actually give explanations that had very formal didactic language that students don't use. And simply saying use less formal language didn't really work, but giving examples of things that were undesirable did work. And specific saying don't use words like while or whereas actually fixed the problem. Another thing you can do is make callouts to publish papers. And you can either do that by giving it the paper to read, or you can do that by simply referring to the paper if it's a paper that's been talked about enough on the web. So, for example, Yadav et al. Said, we want to have deeper contextualization, not surface details, based on using adaptive learning technologies to personalize instruction of student interests, the impact of relevant context on performance and learning outcomes. So they actually gave it an explicit paper title to refer back to, and that worked. Another popular approach that's been very talked about in the media has been chain of thought prompting, where you ask it to think step by step, or take a deep breath and work on this step by step. And It's kind of weird that taking a deep breath works for a model with no lungs. It seems to, though. And it seems to provide better results in not jumping to inaccurate conclusions. Another popular approach is prompt chaining, where a first prompt generates information or a plan that is then used in a second prompt. Now, there are also some ongoing issues. One of them is average reasoning, where if you ask the system what a specific expert would say, if they don't have enough data on that specific expert, they'll give you what a generic expert would say. And in another example, which was GPT-2, my Harry Potter adventure with my kids suddenly turned R-rated, probably based on GPT reading too much fan fiction, and we saw not only how fast I speak during lecturing, but how fast I could slap my hands over my kids' eyes when their Harry Potter adventure turned R-rated. Relatedly, large language models can be too helpful in guessing what you really want, because what you ask for is uncommon or rare or weird. Another issue is over-cooperativeness. Sometimes when you ask a large language model for more detail or explanation, it thinks you're telling it that it's wrong, and it'll actually flip its answer. And this is super annoying when using large language models to label or code data. You've got to kind of design it so that the prompt asks both for the answer and the explanation, but split out in a way that you can still access just the answer. Forgetting over time. Across iterative interaction, large language models can forget the original prompt. And this is particularly likely to happen when you've got constraints at the beginning, like use only 15 words. Another issue, unreliability. The same query can get different results over time. And this happens particularly because with a lot of the vendors, particularly OpenAI, changes in version happen quietly and change the results substantially. And this sometimes results in, particularly with the current focus on safety in AI, in the model refusing to do innocuous things that it used to do. They're trying to make it safe, they make it too safe. They get rid of the R-rated Harry Potter adventures, but then they produce different things like ChatGPT recently refusing to write a scary story for my child and refusing to recommend tourist activities in Philadelphia's poorest neighborhood. Just refused to do it. Another issue that's gotten a lot of attention in the media, more popularly, is hallucinations, where it simply makes up facts or references. ChatGPT is much better about this than it used to be. I've very little seen this happen recently, but it remains a major issue with other large language models, including recently Falcon insisting to me that Cairo, Egypt didn't have a single library in it. Now, as we think about prompt engineering, it's worth asking the question that's come up in some of the literature about whether these tools are simply what Bender refers to as a stochastic parrot. The idea here is that these tools create the most probable next word, and then the most probable next sequence of words. And so some people refer to them as stochastic parrots, which implies no understanding whatsoever. There's still some debate on this, but I don't myself think that's quite right. Because there's some model underlying how the most likely next word is produced, and successful prompt engineering depends in part on being able to think like that model, and think of how to make the answer that you want become the most probable one. So that concludes our lecture on prompt engineering. A lot of tools, a lot of tricks, a lot of possibilities. People are still learning new tricks, and as new, more advanced models become available, some of these tricks will become obsolete, and other new ones will emerge. In our next lecture, we'll discuss the use of embeddings to add more information to a large language model, or foundation model in general, as a knowledge base. Thank you. I'm Ryan Baker. This is Big Data in Education.